And then I hope you can see my desktop. Please, can you see my desktop?
Yes, please.
Okay, awesome. All right. And please, if anybody has any question, please stop me anytime and then just ask your question. So the first time we met, we learned how to do some basic things. We learned how to declare variables. We learned how to get user input. We learned how to do formatted output with what is known as F strings and some other interesting things. Today I'm going to actually make us take a deep dive a bit just for maybe the first 10 minutes, and then the remaining 15 minutes I'll use it to show you something new. Okay. So the first time I was explaining what programming is and how the code we write actually gets converted into machine instructions, zeros and ones for the processor to execute. I mentioned that because there is that large disparity between human language and the language that the processor understands, there is the need for certain tools. And most popular among these tools are compilers and interpreters. And I also explained that Python is an interpreted language because you write your code in a file that ends with the extension .py, and then you basically invoke the Python interpreter, which goes through your code one line after the other and it executes them. That is for interpreted languages. That's my computer slow this evening. That is for interpreted languages. But for oh, okay, now I understand why it's so slow. I opened it all the way from the root. All right, give me a minute. Desktop, and I need to go to TID. Okay, now I can open it here. Yeah. So I also mentioned that there are interpreted languages, and then there are compiled languages. Even though Python is not a compiled language, today I will write a simple code in a compiled language called C, and then we will see what happens in between your C code getting to become machine instructions for the computer to execute, so that you will appreciate what these compilers are doing for you. And then we come back to learning something new in Python. So I'm going to create a file. This is not Python, so don't struggle so much to understand it. I'm just using it to make a case for why we need compilers, and we see the kind of work they do for us. So I'm creating a file called main.c. And by the way, if you are creating, you are writing code in C, your file extension should be c.c. If you are writing code in Python, your file extension should be py, right? I'm going to take this and then I'll do, let me also increase the font here. This should be legible enough. So I'm going to say print, let's say hello world. You see, this code, the one you are seeing right now, is Python. I'm going to show you how we would achieve the same thing in C, so that you also appreciate the ease of Python, so that when somebody is telling you programming is difficult and you ask them what language, they say is Python, um, then maybe they will have a challenge with other languages. Because you see, all I need to do to print something on the screen in Python is to say print, and then I put in whatever I want to print. Let's see what we need to do in C. And again, I'm repeating that this course is not about C. I know C, that's why I'm writing C, but I'm just making a comparison so that you get to appreciate some of the things that these tools do for us. So in C, I need to include something called stdio.h, and then I need to say int main, and then it takes nothing here. It has to return 0 here, and then here I can do print f, and then I'll say hello world, like this.
But sorry, some of the people are saying that you are not letting them in.
Oh, okay. Anytime
Yeah.
people say that, just remind me because I'm not always seeing my screen. Thank you very much.
Okay, sure.
All right. So I'm going to split these two, the screen, so that you see these two code in different languages. On the right is Python. We are doing the same thing. We are achieving the same thing, okay? On the left is a language called C. There is also C++, there is C Sharp, there is Java, there is, in fact, plenty languages. On the left is C. These are some things we need to do to prepare our code before we actually get to do what we want to do. And here we say printf hello world, and I'm putting /n here. It's called line feed. It helps the cursor to come to the next line. All these things are done automatically for you in Python. So you see that in Python, I didn't have to create any main function, but this int main void is what we call a function. It is required in C. We will learn about functions in Python as well. Now I'm going to show you that indeed what we write is not what the computer actually sees, okay? So the C program is what I'm going to compile. But before I compile, in the first session, I told you that all languages, in fact, most of them, especially for the compiled languages, they give you a simpler syntax for you to write your code, right? But in their tool chain, what I mean by tool chain is the compiler and its associated suite of software that is used to translate your code from that high level language to machine code which the computer can execute. A lot of magic happens in between. I'll show you one of the magic now. I am going to show you what this code generates for its equivalence in assembly language. I mentioned the other time that we have machine language. On top of machine language is assembly language. On top of assembly language are languages like C and C++, and all the other languages are on top. So we call these other languages like Python and Co high-level languages. By being high-level, it means there are certain things we cannot do in these high-level languages that we can do in low-level languages. Okay, so C is usually called a systems programming language because it is just a layer above assembly language. And even though it's a layer above assembly language, it has functionalities that helps you to really talk to the hardware, like directly. These things are not possible in languages like Python. And this is why I mentioned in the first video that now you are beginning to learn programming. So it's okay to focus on Python. Understand it as much as you can. I would say give yourself maybe 6 months of everyday learning Python. And it's not just learning, reading books or watching videos, but actually writing code. That is the best way to learn. You can watch all the videos in this world until you actually sit down to write code. You are not really doing the learning. So every day, write code, get the errors, fix them, have the challenges, and then you grow from there. I think someone wants to join. Okay, let me allow this person in. So you do it every day until it becomes second nature. Now, what I was saying is there are certain things we can do in Python, but we can do in other languages. For example, we cannot write what is known as a bootloader in Python. A bootloader is the first piece of code that runs when you turn on your computer. So when you press the power button on your computer, you see some black screen that will come. It does some housekeeping job. When it finishes, before it will load the operating system, and the operating system will set things in place for programs like what we are writing in Python to run. But all these things that happen prior to you, getting your operating system, whether it's Windows, Linux, or Macintosh, we can do them in C, and we can do them in assembly. So this is what you need to consider when you are choosing which language to invest in. But again, if you are learning now, the reason I chose Python is it's very simple for you to understand. Now, after you've understood, last week I used the word, it's like a call. It will call you, okay? Your love and your passion for programming will invite you to seek deeper knowledge. You'll find yourself descending from high level language to low level, lower, all the way to doing microcontroller stuff, just because you want to understand things. But for now, it's okay to start from here. Okay, so I'm going to compile the C code. So I'm going to use a compiler called GCC, and I want you to create a program called main, and I want you to just compile my main.c. So when I do this, it is actually invoking a C compiler to do the compilation for me. But then again, we are comparing C and Python. So I have main dot, it has no extension here. This is actually the binary file, okay? That is why the text editor can't open it. And if I force it to, it doesn't even have a way to open it. Look at something that I see. There are some characters it can't display, but this is a binary file, like it's made up of zeros and ones, which the processor will actually get to see. So let's execute that. I called it main, so I've compiled it, and then you can see that this is the C version. It has printed hello world. And then if I want to run the Python version, I just say python 3 main.py. So you see two different languages accomplishing the same thing. All right. Now the differences will be in terms of what we can do on the hardware, how low level we can go, and also the performance in terms of speed. But I was saying something that it is not a waste that you are learning Python, because Python runs a lot of websites, it runs a lot of backend systems. If you like, you can even do mobile application development in Python, even though people don't do it for production grade applications. But Python now is even in the embedded system space. There is something called MicroPython. So you can put Python in a very small processor. I have some processors here, like something like this. You can program something like this. I have quite a number of them here, and Python is able to run on all of them. There are satellites in space that is running Python on top of this. I'm saying this so that if you meet people, people like to make fun of other people when they say, okay, I am a C programmer, I'm a Python programmer. No. If Python is all you know, use it for what you have to do, but learn other languages so that you don't use the wrong tool to solve every problem that comes your way. That said, let's see this C code, its equivalent in assembly language. So I will do gcc and then I'll say -s main.c. I just want to see what assembly code is going to be generated for this C. So I'm closing the Python one, then I'll open this one, close it here. So on the left is the C code that I wrote myself. It's just 6 lines of code. See what the compiler generated, about 29 lines of code. And this here is another programming language. It's called assembly language. So we can actually compile this thing that the compiler have generated, and it is also going to print the same thing here. So I mean, the first 15 minutes I have just used it to let you appreciate the ease with which we do things in Python, and also give you a teaser and whet your appetite for what you can do after you have mastered Python. There are a myriad of languages out there that you can really learn. Let me see if somebody else wants to join. Okay, nobody. All right. So now that we have seen this, if anybody has any question, please feel free to ask. I'm deleting the C code because that's not what we are learning. And I'm deleting the program we wrote in C also, and I'm deleting the assembly language code also.
Yeah, yeah,
Yeah.
please, is Python case sensitive?
Yes. So all the keywords in the language, I mean, in all languages, they are case sensitive. I don't know a language which is not case sensitive. Maybe Visual Basic, but even that, the community itself will have a convention of how things should be done. But all languages are case sensitive as far as their keywords are concerned. And a keyword is any word that has a special meaning to the language. That's what we call a keyword. Okay.
Okay.
All right. Cool. Okay. So the last time we learned about variables, so we know what variables are. It gives you a place in your computer's memory to store information and also to be able to retrieve it later. Now I want to teach us about what is known as data types. Okay. Um, in the computer's memory, everything is represented as zeros and ones. Okay, for example, if there's a memory block with this 1, 2, 3, 4, 1, 2, 3, 4. If there is any part of my memory that contains 1, 1, 1, 1, 1, 1, 8, that gives me 255. Again, this is something that comes naturally if you do it often. I'm just converting this binary number into decimal, and I know that 111118 is 255. Now, as far as the computer is concerned, everything that is in its memory, including the code itself, is also in zeros and ones. So the question is, if the computer fetches any data from memory, how will it know that this data is music? This data, I need to interpret it as a video. This data, I need to interpret it as a text file. This one, I need to interpret it as some image, okay? It comes with what we call encoding and also the data type. So in programming languages like C, before you create a variable, you need to tell the variable its type. It is not the same in Python. So we call those languages strongly typed language. It's like you have to tell the compiler that this variable has to be an integer, this one has to be a floating point number, this one has to be a character, this one has to be a string. But Python is not strongly typed. So I can at one point in time put a number in the variable, another point in time I can put a string in the variable. Let me show you what I mean. So let's say I declare a variable here, say age is equal to 67, right? And then I can print here. I mean, those who joined last week, you know what I'm doing here. I'm using f strings. I'll say my age is, and then I'll put in age here. So basically, I'm saying it should print, sorry, I'm saying it should print my age is, and then because the age here is in curly brackets, it knows that it has to go through that memory block where I stored 67 and I refer to that place as age because this is a variable. So it will say my age is, and then it will go and read the content of age and put it here. That gives me my age is 67. And that's possible because we have this f string here. Let's see if what I'm saying is true. So I'll say python 3 main.py. So you can see that it says my age is 67, right? Now, let's see something. I'm going to reuse the same age variable, and this time around, I'm going to put here 67, right? If I do this and I run, the first one said my age is 67, 67, and then the other one says my age is 67, as in how it is spelled. The question is, how are we able to store this one you see here is an integer. An integer is any whole number, okay, either negative, positive, or zero. So any whole number, and a whole number, as we all know from our mathematics classes, any number that doesn't have a fractional part to it. So 67 is an integer. How come we are able to store an integer in this variable age on line 1? And then here we are storing what is known as a string. I taught you about strings in the first session. A string is any value you put in quotes is a string, okay? How are we able to do that? I'm posing questions, but I'll answer them through my teaching also. So this is one thing. I'm just proving to you that Python is not a strongly typed programming language, which means you don't have to tell the interpreter the data type you are storing in there. And once you declare a variable, you can actually change the data type. Let me show you how you can check the data type of a variable. So if I want to print what data type age is, like after line 1, what is the data type of age? You just say type, and then you put age here. So the type is a function, and then you give it the variable, okay? And then to tell you that age is an integer. Then here on line 3, I said age is equal to 67 in quotes. So that makes it a string. So I'm going to come here, and then I'm going to print the type of age. Let's see what we get. So I'm going to clear my screen, and then I'll do python 3 main.py. So you see, on the first line, it says age is an integer. It says class int. Like if you see int, it means it's an integer. Then if you see str, it means it's a string, okay? I'm just doing this for you to know the different data types out there. I can also come here and say age is equal to 67.0. Then I'll print the type of age. So is there a question? Okay, wants to join the call. So I'm going to run this again. So you can see that the first time age was an integer, the second time it became a string, the third time it became a float. Now the question is, what is a float? I explained to you that integers are whole numbers, whether negative, positive, or zero. So any whole number is an integer. And a whole number is just a number without a fractional part, right? Now, when on line 5, I said age is equal to 67.0. Let's see the data type that we got. The data type is float. In computing, any number that has a fractional part, we call it floating point data. There's a whole explanation as to how they are represented in the computer, and I don't want to bore you with that yet. In fact, in other languages, there isn't just the floating point data, but they break it into two, either float 32 or float 64. In other languages, they have just the float for when the precision is not long, and then there's a double for when the precision is very long. For example, you know that there are some numbers that cannot be represented accurately. An example is pi, right? 22/7. That's why we say it's irrational. In fact, you can start from one end of the world. If we gave you the whole world as a blackboard to calculate pi, you can write everywhere in the world, and by the time you finish with the last space left for you, you still haven't finished calculating the value of pi. So computers really do have challenges when it comes to handling floating point numbers, and when you are dealing with them, you have to be careful. But this is what we have. So it's knowledge that you need to have so that you know how to work with them. Now that we have seen the different data types, I'm going to tell you what a data type is, and then we do some examples. So the question then is, what is data type? I explained earlier that everything that we declare and store in variables at the end of the day are represented as zeros and ones in your computer's memory. So for your program to be able to rightfully interpret them, okay, because a string of binaries like 1111, it could be a part of some music, it could be a part of some video, it could be a part of some image, right? So if your program has no idea, then how does it interpret what is going on there? It is the same as human language. It's like there are certain words that mean one thing in your language, and the same word means something else in another language. The question is, if languages didn't have a way of interpreting what we hear, then there will be chaos all over. So computers also need a similar system. Like if I see strings of zeros and ones, yes, I'm seeing zeros and ones. What do I do with them? It is the data type that tells your program that, okay, as you are going to this portion of memory, the zeros and ones you are seeing there, interpret them as an integer. Then it knows how to calculate or decode those strings of bit as integers. If we tell it it's floating point number, it will know how to handle it. If we say it's a string, it will know how to handle it. So that's what data types do. And I've showed you how you can check the data type of your code, right? So I'm going to write some examples, and then I want it to be interactive. So I'm writing some code. I want somebody to unmute yourself and tell me what the answer is going to be. So I'm going to say first number, and I'm going to put 10 in quotes, okay? And then I'll say second number. I'm going to put 20 in quote. Then I'll say total is equal to first number plus second number. Then I'll say print. I'm using printf here. I'll say the total is, then I'll put total here. Who can tell me what this program will produce as an output. And don't worry, it's okay to get it wrong. Yeah, please speak. Ernest.
Um, will produce 1020
Okay.
a string.
Okay. So Ernest
So
said it's going to produce. I'm going to put. I mean, people's answers here. I want another person to speak. How come I can't spell Ernest? Okay. Ernest said it's going to produce 1020. Who else wants to try
yeah,
before we run it?
It's going to print the first number and the second number, giving us that it's a class.
Okay.
So
So this is Ajua speaking, right?
Yes.
Okay. So Ajua
So
said it's going to give us 30. All right.
uh,
Another attempt. Anybody else?
okay. I think it won't produce like mathematical, but it just prints the 20 and the 10 for us.
Okay. So you are saying something similar to what Ernest said, right?
Yes, exactly.
Okay. So Ernest and Robert. All right. Moment of truth. You see, I like computers because computers are the most obedient things I have seen in my life. Very, very obedient. And whenever I see programmers fighting with their code, I tell them that code doesn't lie. The computer is doing exactly what you've told it to do. So if your code is not working, don't blame the computer, blame yourself. Let's see. Somebody wants to try? Steven. Yeah.
It's going to give a syntax error.
Okay, so let's see. Steven. Charlie, my spellings is getting bad. Oh. Steven Kranami breast. Steven says syntax error. Okay, all right. Moment of truth. And there we have it. So Ernest and Robert got it correct. And I know why Ajua said 30. But now I'm going to explain why she got it wrong. So Ajua, please listen. You see, when something is in quotes, right? Regardless of the content of the code being numbers, the computer doesn't see it as a number in the mathematical sense. Do you get what I'm saying?
Yeah.
Yeah. So as far as the computer is concerned, this first number here is 1 followed by 0. It's not 10. Okay. It's the same way if I do Ajua here, and then I run this. It will print Ajua 20. You see? Because I put it in quotes. So the computer sees A followed by D, followed by W, followed by O, followed by A. And then it sees another thing, which is 2 followed by 0. And then we are telling it to put these two together. So what is happening is called concatenation. It is not addition. So even though you are seeing plus here, in Python, the operators are overloaded. When we say it is overloaded, it means the same operator behaves differently depending on the data types that you give it. So at one point, plus will be doing actual mathematical addition. At another point, it is going to do concatenation. At another point, it can even throw syntax error. If somebody has a question, okay, Nana Harrison, yeah, concatenation. So that is what is happening here. What would have made Ajua correct is if they were not in quotes like this, at which point it becomes integers, okay? So then this becomes 10 plus 20. In the first one, it was 1 followed by 0 plus 2 followed by 0. If you put them together, you get 1, 0, 2, 0. But now, with this quote removed, the data types for first number and second number are actually integers. So now if I run this, we get what Ajua was saying. So to make it more easier for you to understand, I'm going back to where we were. And then I'll put in print statement to tell us the data types, okay? So I'll say data type of first number. So here I'll say I want the type of first number. And then I'll come to the next line. And by the way, feel free to leave lines in between your code. It doesn't affect the output. If a line is there, is an empty statement. And then I'll put second number here, and I'll put second number here, and I'll put this also in quotes. So now they are both strings. Now let's see. So you see, the data type of first number is a string. The second number is a string. So when you put a string and a string together, concatenation happens. So we get 10, 1, 0, 2, 0. But if I remove the quotes, you see that the data types will change to integers. You see? So in the first instance of the program, first number was a string. Second number was a string. So when we use the addition operator, we got concatenation. But in the second instance, first number is an integer, second number is an integer. So when we put an integer and an integer together, we get an integer. That is why we are getting 30. Now, let's see what will happen if one is an integer and one is a string. Okay, so look at it very well. First number is an integer, second number is a string. And then I'm trying to add a string to an integer. Let's see what's going to happen. So now we get Steven's answer. So I intentionally went through it this way so that I will let everybody know when they are correct, right? So Ernest and Robert were correct. Their answers were correct. Ajua got it wrong in the first attempt because she forgot quotes around it, makes them a string. And Steven said it was going to be a syntax error, but no, it is not. It's a syntax error only when the operands you are giving to the operator are not the same. So look at the error. It's saying type error, unsupported operand types for plus, int, and str. So the plus operator is telling you that, bro, you gave me an integer and a string, and you're telling me to put them together. I don't know what to do with that. Okay. Meanwhile, there are some operators that will actually do this. Let's see times. Let's see times. What times is going to do? So you see, if I use times, it actually prints what is on the left, the right hand side times. I don't know how to put it. Let's see. I said first number times second number. First number is what? 10, right? And then the second number is 20. So it printed 20 10 times. If we count, we should have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. So these are some of the surprises in programming. And this is why I said it's not enough to watch videos. Some of these things, if it were a video, it will not even occur to you that, oh, this is a string, and so it will not work. But if you actually get your hands dirty, then you get it to you get to see what is really happening. With this done, I'm going to now let us write a program that will actually ask the user to enter two numbers, and then it will sum them, and then it will tell us. For those of you who already have Python installed on your computer, I'll be glad if you attempt it. Then when you finish, let me know. I will let you share your screen, and then we see what you got. But I'm also doing it here for the whole class. But if you already have Python on your system, attempt it. I want you to write a program. In fact, let me write it as a comment here so that those of you attempting can do that. So write a program that accepts two numbers as input from the user I can put it in one sentence, from the user, and print the sum of these numbers. Okay. All right. So for those of you who want to try, please try this. I'm going to do it the first time. I will intentionally get it wrong. Then I will fix it again to show you something. So I'm writing my code. You know that to receive input, you use a function called input, and then you give it a prompt. The prompt is what it is going to show, right? And so it shows the prompt, it waits for the user to type the user input, presses enter, and then it reads the value into the variable on the left. So I will say first number is equal to input. I'll say enter a number. Then I will put this semicolon there. I just want it to look nice. I'm stopping here, so we run it, then we'll see what I mean. So I'll do this. So you see, I just said input, enter a number. So what is going to happen is it will print this as a prompt. That is what the user should see. And this is very important in programs that runs in the terminal. For example, if you went to your ATM machine and the machine never prompted you that, okay, this is time for you to insert your card. It is time for you to enter your PIN. It is time for you to take your cash. You will stand there and then you don't know what to do, even though code will be running, right? So it is good to prompt users whenever you need information from them. All right, so it says enter a number. I enter 100. Well, once I've done this, it means 100 has been stored in this variable, first number. Please let me take this water. But the question is it really 100 that has been stored in first number, or it is 100? We'll find out. So I'll do second number. And those who are trying, when you finish, just let me know. I'll let you share your screen. Input, enter another number. Okay. And then I'll do the total. So I'll say total is equal to first number plus second number. Then now I print the total. So I'll say print. I'll use F strings here. So I'll say the sum of, then I'll put the first number here and second number is total. Okay, now let's see why I'm wrong in this program. So I run this. It says enter a first number. I put in 100. Enter another number. I put in 200. What are we expecting as an output? Let's do that trial again. So Adjoa, what will we get as the output? Can you guys hear me?
1000200.
100200. Okay. Robert, what will we get? Pardon?
Sorry, I'm doing it, so I'm not focusing on what you are doing.
Okay, but you just guess. Look at my code and then just try to tell me. You don't have to get it correct. I'm taking two inputs from the user and I'm putting them together. Shouldn't that be 300? Because I entered 100 and 200.
Hello?
There's someone talking. Let me mute this person. Anybody wants to try again? Okay, now let's see that.
I think I agree with
Pardon?
I think I agree with Adjoa.
Okay, so Robert is also saying the same thing. All right. And this time they are both correct. You see, I said the sum of 100 and 200, but it gave me 100, 200 just put together. Why? The reason is that whatever you get from input is a string. If you like, we can check the data type. Yeah, Nana Harrison, please go with your question.
No, sorry, it wasn't a question. I've tried it and I just wanted to show.
Okay. So you got it correct, right?
Well, I've run it, yeah.
Okay. Share your screen and then take us through.
Right. Give me a moment. Can you see my screen?
Yeah.
Can
Okay.
you see my
Yeah.
Okay. So what I did was, so we're getting two numbers. So enter the first number, and then enter the second number. Okay, we're using an input. Okay, I could have I wrote the second one. Where is it? Oh, right. Okay. So then I'm doing the sum of num1 and num2.
Mhm.
Okay, and then output. So I put in a string which are words, and then the sum of 1 and 2. Now they are curly brackets in this case.
So that
They
makes
are
them
not
placeholders.
exactly, and
Okay.
then they output the results.
Okay.
So what I did was, okay, let me go. Sorry, I tried that method. So let me run it. If I run it, so it says enter the first number, say 10. Enter the second number, say 12. Enter. So the sum of, so what I said is that the sum of 10 and 12
Mhm.
is 22.
Okay.
Now, something just came in mind. So let me do something again. Sorry. Something just came in mind.
No, feel free.
Sorry. Oh, yeah. Okay. So let's say 12.5. Something just came in mind. 12. Okay. Right. Okay. Yeah. That's it.
Okay. All right. So please keep your screen shared. The reason why his code is working, you see, apart from the input, he has nested the input function call into something else we haven't seen. It's called float. Okay, even though you know float data type, but this float he has used on line 2 and line 3, they are functions. And what he is doing there, we call it type casting. Okay, so he is casting the string into a float. And the reason why it's good he chose a float is if he casted into an integer, this example 12.5 plus 12, he will get a wrong answer because an integer cannot have a fractional part. So what Python will do is it will truncate the fractional part and treat 12.5 as 12. So he would have gotten 24 instead of 24.5. And if you make such petty mistakes in programs that people's life depends on. For example, this Boeing 784 aircraft, there was a situation that caused, I mean, after if the aeroplane runs for 280 days, on the 280th day, all the six engines will fly in, all the six engines will operate in, I've forgotten the right word, but it will go into the mode as if the aeroplane is falling down. And if the aeroplane is falling, like pilot has lost control and the aeroplane is coming down, so the engines have to overwork so that the plane doesn't come down like a stone. I hope we all know that when an aeroplane is falling, it doesn't fall like a stone, right? It's not like boom, then no, it doesn't happen like that. It glides. It glides. It's like you've opened an umbrella and then you hold on to it. You won't come down like a stone if your umbrella is strong enough. If it's a bad umbrella, then it will become like this, and that shape will actually make you very aerodynamic, and then you come like a stone. But if it's able to hold onto the pressure of the air with your weight, you will actually come down gliding. It's like the way they do paragliding in Kwowu. Now, the problem that was causing this in the Boeing aeroplane was something we call overflow in C. So on after every 280 days, the data type they chose overflows, and then it wraps around. And what it means is that it is risky for all those in the flight, and then they will actually waste fuel because the airplane is flying as if it is falling and it doesn't want to fall, and it's risky. So of late, code, I mean, people's life depends on code. You go to the hospital, you see people with heart pacemakers, people with oxygen machines on them. It is code. And this is why the fundamentals of your coding journey should be very strong. Okay, so he chose a float here, which I like because otherwise his calculator cannot handle floating point numbers. Okay, so thank you very much, Harrison. Please stop sharing and then let me take over. Thank you very much.
Okay.
Okay, so I'm going to share again.
Please,
Do you have a
somebody's
question, Enoch?
asking you to let him in. Yeah, somebody's asking you to let him in.
Okay, but I'm not seeing anybody here. Let a person try to join again and I will see. All right, so the reason is the data type that we get from input is actually a string. Okay, the person is not here. So let's confirm. I'm going to print the data type. So I'll say print. I'll just print the type of first number, and then I'll copy this. I need to say type, and then after second number, okay, now the person is here. So after we get the second number, let's also print the type of second number before we do our summation. And then we confirm. So here I'll put 50 and then 50. We expect 100, we'll get 5050. Why? Because first number was a string and second number is also a string. Okay, so I have a I have a variable that is in one type. How do I cast it into another type? The way we do that is you can cast a variable into another type and put it back into that same variable. So I can say first number. So the first number which we got on line 4 from the input function, which is a string. Now we want to say it should be equal to, I'm using an int here to prove what I explained when Harrison shared his screen. So what I'm saying is that first number which we got from the input of the user, which is a string, now convert that into an integer and then store it back into first number. Remember, Python is not strongly typed language, okay? And then we do the same for second number. So we say second number is equal to int, and then we'll put here second number. Now, let's run this program. I do 50 plus 50. Now we get 100. Why? Because I converted it to an integer. I converted second number also into an integer. Let's run it again. And then I want to add, let's say 10.5. Okay. And I get it wrong. I get a value error. Why? Let's read the error. Whenever you see an error in your code, don't panic. Take your time, read that error message and analyze it. You will understand. When you are beginning and you get error, you panic and then you don't know what to do. Don't. Just read the thing and you understand. It says invalid literal for int. So he's saying that you gave something to convert to an int, but that thing is not an integer. So invalid literal for int with base 10. You gave a base 10 number and to convert, and it doesn't know how to handle this as an integer. In some languages, it will actually truncate the 0.5 and treat it as 10. So here is a good thing Python has done. Python says, if your code is not right, I will not let it run at all. There are some languages that will say, okay, as far as your code compiles, run it. But that is where lives can be lost. Okay, so they are being careful here that what you gave cannot be converted into an integer. So they crash your program so that you don't go and then destroy something. Some of these things, they seem trivial until a big issue comes out of it. There is this crime in that started. I don't know if I remember the spelling right, but it's called salami crime or something. Can you guys hear me?
Yes. Yes,
Okay.
please, we can.
All right, cool. So see, there's this salami crime, okay? It was actually perpetrated by a programmer who was working in a bank. He made himself very wealthy. Do you know how he became wealthy? You can read about it after this class, but I'll give you the summary of the story. So this guy was, a programmer who was working on the software that they use for the pay slip. To calculate the salary slip, of the employees, right? Now, how many of us here pay attention to the fractional part of our salaries? Most of us, we don't even know, we don't care, right? But the truth is, nobody, let's say if your take home salary is like 25,000 Ghana cedis, nobody actually takes home 25,000 like on the dot, boom, unless you are not taxed and all those things. By the time they tax you, because of the calculation of the tax, there's some fractional part of your salary. And this part, we see it so insignificant, we don't care about it. So Salami realized that people truly don't care about this. If it's not there, they won't find it. Like your salary is 18,255.40. The last time you saw the 40, you don't even know. The truth is, in your mind, it's not even there. So what the Salami guy did was, all these fractional parts that nobody really cares about, let me channel it into my account. So imagine you build such a software and you get global clients who are using it to process hundreds of thousands of payrolls each month. Let's do some calculation. If I do, let's say, let me run Python interactively, and then let's say everybody's fractional part is, let's say, 0.45, right? And then this guy processes, they use his program to process 100,000, so 100,000 payrolls every month. Look at it, 45,000. Okay, so this is how this Salami guy in his code became wealthy. He was chopping off these fractional parts and channeling it to his own self. And then they realized that this dude is becoming rich. We are all working in the same company. Probably I get paid more than him, but he's living a more lavish and extravagant life. And they found out that he was manipulating the fractional part of the salaries that people don't care about. This is an unfortunate situation of fraud. But just imagine that you are writing code that actually flies an aeroplane, or code that operates a lift. Or code that launches a rocket into space. You can't go wrong. There's an escape velocity. There's an angle at which a rocket should point before it can escape the gravitational force, and also the velocity. So if you are careless about your choice of data types, you're like, oh, gravity 9.8. When we were in school, they said taking gravity as 10. Let's just assume let's just assume gravity is 10. You can't be assuming like that in the real world. And if, because you thought you can use 10 as gravity, you stored it as an integer, that is how a rocket will reach where it has to leave the atmosphere, and then it will land somewhere on some football stadium. So today's class has been mainly about data types, and I hope I have done a good job to help you understand what these data types are, how to convert from one to the other. These are very fundamental data types. God willing, in the coming weekend, we will learn about more complex data types, list, dictionaries, sets, and then subsequently we also learn how to create our own data types. I will pause here and then I will take questions if any.